Hello everyone, Mr. Minix, my name. Math is my game. This morning I'm joined by my first period Algebra II. You can tell they're excited to be here today. It's Wednesday. Some people call Wednesday hump day, as in we got to get over the hump. So chapter 3, section 2, solving systems via algebra. Content standards, ARE, I6. You don't need to know that. One day Mr. Dobrin's going to come in. He wants to see that. But anyway, the state of Ohio, the Common Core content standards, they say that we need to cover this stuff, so that's why we're covering it. The goal, the objective, by the end of this, you should be able to solve systems of linear equations using algebra. So we're ready to get right to it. Big ideas, there's two of them. There's two methods that we're going to use. One of them reminds me of little Mrs. Fisher, not tall Mrs. Fisher, who's in the office every day, but little Mrs. Fisher. No, little Mrs. Fisher. She looks like she could be Danny DeVito's sister. You know who I'm talking about. So I guess this also reminds me of that other lady who wears the red sweaters and glasses and tells jokes about elephants. Miss Dempsey. So what are we talking about? Subs. What? Substitution. So that's the first of two methods that we're going to look at today. And if you've forgotten what substitution looks like, how it goes, here's the general algorithm, the procedure, the goal, the objective, what you should be doing with substitution. What you need to do is solve one equation, solve one of the two equations. So you're going to solve one equation for 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 one variable in terms of the other, That's the first half of it, the first part of that. The good thing is sometimes that's already done for you. If you had an equation, and you'll see in a minute, and I know this is probably just going to go right over our heads, but if you had one equation in standard form and another equation in slope-intercept form, we're ready to rock and roll. Okay, you'll see in a minute. So then we're going to plug that. We're going to plug that, and you'll see what that is. I put it in quotes for a reason. We're going to plug that into the other equation. So the idea is it's hard to work with two different variables. In Algebra 1 and pre-algebra, you learned how to solve equations, and you could solve equations that had just x's in them. But you throw x's and y's together, and it's virtually impossible to solve. So the cool thing about this is when you do this, you're going to have a really long, drawn-out, horizontally big equation. This creates one large, I'm going to say large, equation. It's going to create one large equation. But the cool thing about that one large equation, that large equation is going to have just one variable in it. So this will create one large equation in one variable. The rest of it, I think you'll kind of understand. The second half of it, I'm not going to write up in this algorithm because it's the same for both, and we'll kind of see what that's all about. Remember, systems of equations, the answer's an ordered pair, right? So we'll want to have values for x and y. So in substitution, the starting point is solve one equation for one variable in terms of the other, then plug that into the other equation. This will make one big equation and one variable. And that's kind of where we begin. We ready to see this in action? Okay. All right. We're not actually going to solve this first one. We're just going to kind of discuss what it means to set one of these up. So suppose our system looks like this. 2x minus y is equal to 11. And suppose our other equation is this. Negative 4x plus 8y is equal to 32. So we said we need to pick one of the two equations and solve one of the two equations for one variable in terms of the other. So what we're looking at is we're looking at either taking this equation here and solving that for x in terms of y, or y in terms of x, or taking this equation here and solving it for x in terms of y, or y in terms of x. What do we think would be the most simple thing to do? What do we got? The top one. So what variable would we solve the top one for then? We would solve the top one for y. Does that make sense to most of you? So if we take that top equation, that 2x take away y equals 11, it would be pretty easy to solve that one for y. The reason is its coefficient is -1, and the negative's not so good, but the 1 is awesome, right? Because that way we're not going to deal with fractions. And let's face it, fractions, well, you guys don't like them, do you? Okay. So if we did that, then what would we end up with if we solved that for y? We would have y equals, awesome, good start, y equals, somebody said it, y equals what? So what I would do is I'd take this negative y, put it on this side of the equation, right? So that's where that y comes from. So y equals what? 2x minus 11. Awesome, thank you. Good. Y equals 2x minus 11. So let me go side by side. Hopefully if you're sitting in the back you can see this. Do you see how I put in quotations that? So I put that in quotations. Guess what? All right, so we're asking the question, what's the that? We're going to plug that. What's that exactly, specifically in this problem? What is that? Something about the equation. What did we say about the equation? 2x minus 11 is the that. Does that make sense? 2x minus 11, 2x minus 11, this right here is the that we're talking about. Does that make sense? Good. So if we do this, remember, we're not going to solve this all the way. We just want to explain kind of the setup. If we were to do this then, so we're going to plug that into, it's real important here. Remember, we said we got to plug that into the other equation. If you don't, you're going to end up running around in a circle. Anybody ever run in a circle? Or get lost in the woods and you walk around the woods and you're like, dude, I've been here like 7 times before. Anybody ever do that? So we need to plug that into the other equation. So the other equation is negative 4x plus 8y is 32. So where into the other equation are we going to put that? We're going to put it in parentheses next to the 8 because it's going to take the place, that is going to take the place of y. Does this setup make sense? I really hope it does, because if you understand that, this is going to be really simple. The rest of it's just doing some algebra and being neat and precise about your algebra. So we would have negative 4x plus 8 times the group of 2x minus 11 in parentheses. That would equal 32. And as promised, look at what we've got. We've got one large equation in one variable. Then we can solve that equation for that variable. Then we'll take that variable, plug it back into one of the other original equations to get the other variable. But the setup is really key here. I will ask you to solve systems via the substitution method, and I will be looking for those kind of steps, that kind of evidenced work. And I will ask you to solve one the other way as well. So before we proceed, I would like to give a shout out to Mr. Dobrin. I'd like to give a shout out to the future Mr. Minnick. And maybe one more person. Maybe to Nighthawk. If you don't know who Nighthawk is, well then you got a lot to learn. All right. So let's see what the book said. The book said, you don't need to write all this down. The book said, when trying to solve by graphing, the coordinates may not be obvious. That's true. That's why we have to use this algebra method. Sometimes our answers are going to have that F word in them. Sometimes our answers are going to be fractions, and fractions don't show up on the graph so well, do they? Maybe halves do, maybe fourths do, but thirds, fifths, sixths, sevenths, they're very difficult to discern on a graph. So the book says you can solve a system of equations by writing equivalent systems until the value of one variable is clear, then substitute, yada, yada, yada. Okay. So right here, you could use the substitution method, yada, yada, yada. They're saying what I just said. So here we go, example 1. Example 1, we are going to work through this one. And when we're all done with this, you're going to see, when we're all done with this, you're going to see something that's going to make you say, why did we just do all that? You know how teachers do. They show you the most difficult ways of doing something, and then at the very end, they show you the easy way to do something. But remember, on the quiz, I will ask you, and so that I know we've covered the Common Core content standards, you will be asked to do these by hand. So, okay. 2 equations. We got to pick one of them to solve for one variable in terms of the other. Second one, and solve it for y in terms of x. So we're going to take the second equation. We're going to solve it for y in terms of x. So we're going to have y is equal to what? I'm hearing 2x plus 10, and I'm hearing negative 2x plus 10. Yeah, it's going to be negative 2x plus 10, right? Because this 2x would go to the other side of the equation, right? Everybody good with that? Well, what is our that? The negative 2x plus 10 is our that. And so we're going to take our that. I know it's kind of weird to call that. But we're going to be plugging that into the other equation in place of what? In place of y. So now we're going to take 3x plus 4y. But y isn't y anymore. Why is that? Why is that? Because that is negative 2x plus 10. And then that's all equal to 12. So here we've got our large equation. There's one caveat to the large equation. Make sure you use the distributive property properly. Don't forget the distributive property. 3x, really no change there. 3x is good. Let's use this distributive property. What's that first term going to be after that? Minus 8x, awesome sauce. And then what? Plus 40. Good. So plus 40, and then that all equals 12. So solving this the rest of the way, combine our like terms, we get negative 5x. I'm going to go ahead and subtract 40 from the other side, if you don't mind. Hopefully that doesn't offend anybody. Dude, this isn't going to work out nice, is it? That's going to be, is that negative 28? Is that negative 28? Okay, so we divide by x, or divide by negative 5 rather. So x is going to equal how much? A negative divided by negative is going to be positive 28 over 5. Hopefully we did all that right. I don't see anything wrong with it so far. Fractions. Oh man, oh my gosh. Ugh. So how should we go about getting the value of y? Plug it into which equation? The first one? I wouldn't plug it into the first one. I'd plug it into the, remember when we did the that part? I would use that. Some of your algebra teachers tell you to go back to one of these. In Algebra 1, your teacher said, go back to one of these to find your other variable. Well, guess what? I'm not going to. I'm breaking the law. Breaking the law. That's not breaking the law. But I'm going to use this because this is already solved to find y quickly, isn't it? Why not use that? Why not use that? So then y is going to equal negative 2 times 28 fifths. Times 28. Oh, I'm using my magic marker. That's not going to show up. It's going to be gone. There it goes. So y equals negative 2 multiplied by 28 fifths plus 10. Negative 2 times 28 fifths. Fractions. Got to multiply across the top, multiply across the bottom. So that's going to be negative 56 fifths. And 10. I need to turn 10 into some fifths. So I would multiply the 10 over 1, by something that's going to make it fifths. I'd multiply the 10 over 1 by a 5 over 5. So that's 50. That's 50 fifths. And so what's negative 56 fifths plus 50 fifths going to give me for the y then? Negative 6 over 5. Wow. Wow. Kind of crazy. Is that good enough for our answer? We got to write our answer as coordinates or ordered pairs. So our answer, our A and S dot, our answer is that we have something comma something. X comma y, 28 fifths, comma, negative 6 fifths. Maybe we won't wait till the end. I said I'd wait till the end. Maybe we won't wait till the end. Let's do it right now. You're going to hate me when you see this. And I know hate's a strong word, but you're going to hate me. You're going to be like, dude, how come we just can't do this? You know, you might have seen this in Algebra 1 last year, but, you know, we have the school bus yellow TI Inspires, right? Because of this, I could sell millions of TI Inspires because of what you're about to witness. It's going to take a minute to load. While it's loading, I can't help but think about that theatrical production that I'm in the midst of writing, a drama, a skit. I'm writing it about puns. I tell you about that one. It's really just a play on words. So, at least I didn't talk about the Mario Brothers. You know, the Mario Brothers wear some really cool pants. Denim, denim, denim. Denim, denim, denim. Denim, denim, denim. I like when they do the really low part, when they do the octave drop. That's awesome. Okay, so notice I'm using a calculator page here. Has anybody ever used one of these things and they see the press to test mode? Press to test mode won't let you do this, but check this out. If I don't know what to eat at Wendy's, I got to look at something. What do I look at? The menu. Now, what class is this? Algebra. So what option do you think I should probably choose? Option 3. Now, we're solving systems of linear equations. Which option do you think I should choose? I have 2 equations, and the variables are x and y, so I'm okay there. I said I'm okay there. It says lin solve. Now let's see. Our one equation was 3x plus 4y is 12. 3x plus, plus 4y is 12. Our other equation, wasn't it 2x plus y equals 10? 2x plus, not plus z, plus y equals 10. Not 11, but 10. You ready for this? See how fast that was. But why can't we do that all the time? Because the Common Core Content Standards say you'll do that by hand without a calculator. All right. Are there any questions at all about solving one equation for one variable in terms of the other, plugging that into the other equation, getting that large equation? Any problems or questions about the procedure, the steps? Okay, if not, I'd like to do example. Well, we'll look at their Godding real quick. Looking at their Godding, what equation should we use and what variable should we solve for? First, and solve for x, right? So if we did that, we would have x equals what if we take this first equation and solve for x? X equals minus 3y plus 5. Awesome. So then this is our that, and what would we plug that into? Into x in the what? In the other equation. So this would take the place of x in the other equation then, right? So then we would have Negative 2 multiplied by the quantity of negative 3y plus 5. Close that. Take away 4y, and that equals negative 5. Dude, that's so many negatives. Wow. Wow. It's a lot of negatives. A lot of places to go wrong here, right? Let's distribute the right way. What do we get? 6y minus 10 minus 4y, and that's all equal to negative 5. Good. So then we get 2y is 5. We get y is 5 halves. Where should we go to find x? Did I forget a 10? Did I forget it? No, I took the 10 over. I skipped it. I went like warp speed there. Yeah. We went like 7 parsecs into the future. So the mothership told me not to mention parsecs, though, so I didn't say that. So how am I going to find x now? I bring it up into the... Can I use this one to find my x? Okay. So then x is negative 3 multiplied by 5 halves plus 5. So that's going to be negative 15 halves. I got to make 5 into halves. What do I do? Multiply it by 2 over 2. So then I would get 10 halves. So then what do I get? Negative 5 halves. So x is negative 5 halves. So my answer would be negative 5 halves, positive 5 halves. How we feeling? We got this? We got this on lock? Do we want to see the calculator with that? No, it'll just ruin your day. Okay, so I want to show you a trick system. This might show up from time to time. Solve this system. X equals 6 and y equals 8. What's the answer? Okay. You know how many people struggle or fail to solve that one? I don't know why, but some people do. It's kind of like missing a layup. I was talking about layups in one of my classes yesterday. It's like missing a layup. Okay. All right. Well, we got this other method to talk about, and this other method, I don't like what some books call it. Some books call it the elimination method. I usually call it something else, but I'm not allowed to say it anymore. I almost lost my job for saying it, so I'm not going to say it. It has to do with SpongeBob in that one episode where they say people order our patties. But anyway, another name for this is linear combinations. So this is kind of a tricky setup. If you thought the setup for substitution was bad, this is even worse. This is even worse. It's not super difficult, but here's where you got to start. Both equations must be, actually they could be in a modified form of this, but I'm going to say they must be. So that's equations. I use a lot of abbreviations. Both equations must be in that one form that you don't want the abbreviation to. Standard form. Both equations must be in standard form. Okay. And what you want to have happen is you want the coefficients of either the x's or the y's to be either the same or the opposite number. Say that again. So you want the coefficients of either x or y to be either the same. Now, I do this a little bit different than some of your other algebra teachers have done this. Some of your algebra teachers say we're only ever allowed to add equations. Well, they lied to you. You can actually subtract one equation from the other. That gets confusing sometimes, but maybe we'll try it. So we want the coefficients of either x or y to be either the same or, more desirably, the opposite. So what I mean by that is we want to have something like 7x plus 2y is 8, and 7x plus 5y is 9, something like that. So in this particular case, our coefficients of x are the same, right? Everybody see what I got going on there? So that's where the coefficients are the same. Or maybe we want to have something like this. 7x minus 2y is 8, and 5x plus 2y is 15, something like that maybe. So in that blue system, what we've got there is the coefficients of y being opposites. Okay. How are we feeling so far? Can anybody see why we would want to have most desirably the coefficients of our y's to be opposites like that? Remember, this is called linear combinations. This is called the elimination technique. Why would we want to have the coefficients of the y terms to be opposites like that? Yeah. They'll cancel each other out if we combine those by addition or subtraction. So in this case here, can everybody see that? Is that big enough to see? In this case here, if we were to take those two equations and add them, the y terms are going to cancel out if we add those two equations. If we took these two equations and we subtracted them one from the other, what would happen? The x terms would cancel, right? We feeling all right? The problem is when we go to solve these, they're not always going to be set up nicely for us. So the deal is sometimes we might have to multiply one equation by something. Sometimes we might have to multiply both equations by something in order to make them look that nice. We ready to try one of these? All right. Here we go. Here we go. Hey, look at that. Boy, example 3, they're awesome. The book's authors with this particular example, they're my friend. Why? It's already set up. What can we eliminate right off the bat? The x's. So the deal is we're going to take those two equations. We're going to add those two equations in a vertical fashion. We've got 4x plus 2y, and that's 9. We've got negative 4x plus 3y, and that's 16. And what we're going to do is we're going to add these things right down the columns. Down that column, down that column, down that column, down that column. All right? So what do we get? 5y, awesome. 5y equals 25, good. And when we divide by 5 then, we're going to get that y equals 5. So we're halfway done. When I solve these, I kind of like to have my answer, written somewhere. So my answer I know is going to be something 5, right? I'm halfway done. What I don't like about this technique is sometimes getting the second half of it's a little bit tougher, right? You see why? Not that much more difficult, but sometimes getting the second half. So what are we going to use to find x then? First equation or second equation? It honestly doesn't matter, but yeah, I would use the first because I don't like working with a lot of negatives. So we're going to use this first equation then to find x. So that tells us that 4x plus 2 times whatever y is 9. Well, we just found y, didn't we? Y is 5, so we got 4x plus 10 equals 9. So what do we get? 4x is going to equal negative 1. Now, a lot of people at this point will invert their fractions. I remember from the second week of school, some of you were flipping your fractions over. So a lot of times we expect integer answers. What's our x going to be here? 4, negative 4, negative a fourth, or a fourth? Negative 1/4. Fractions happen, and they're okay. All right, fractions happen, and it's okay to get a fraction for an answer. So we divide by 4, and we do get 1 over 4, not 4. So our answer then, our solution, is negative 1/4, comma 5. Wouldn't it be nice, though, if you got to use the TI Inspire? Menu, algebra, solve. Two equations, 4x plus 2y. 4x plus 2y equals 9. Negative 4x plus, was it plus 3y? And that equaled what? Thank you. Wow. How come we get Sorry. Sorry. So, again, linear combinations. Both equations need to be in standard form to start. We want the coefficients of either x or y to be either the same or opposites. And then we add or subtract the equations. How do we feel about that one? Pretty good? Let's look at one where they're not set up so nice. I said let's look at one where they're not set up so nice. Oh. The coefficient of x's are 2 and 3. Are 2 and 3 the same? No. Are 2 and 3 opposites? No. 7 and 5, are they the same? No. Are they opposite? No. Oh, man. So this kind of starts us thinking about GCDs and LCMs and all that jazz. We'll be talking about all those things later. So what do we want to get rid of, the x's or the y's? X's? Okay. So if we wanted to get rid of the x's, let's think about the numbers 2 and 3, and let's start thinking about the LCM of 2 and 3. 2's multiples are 2, 4, 6, 8. Who do we appreciate? And 3's multiples are 3, 6, 9, 12, etc. So 6 is kind of what we're shooting for, right? So the deal is we would like to have 6 x's, and then the second equation, this is our first equation, and then our second equation, would we want it to be positive 6x or negative 6x? Negative, because the less subtracting we have to do, the better we're going to be, right? So we'd like to have our second equation to have a coefficient of negative 6x. So in order to make this happen, in order to make our first equation have a coefficient of x being 6, we need to take it and multiply it, the first equation, by 3. Everybody with me so far? So we're going to triple every single term in that first equation. Here's where people mess up. They don't. Let me say that again. Where people mess up is they forget the distributive property on the second or the last term. So we do get 6x, and then what? Plus 21y, and then that's going to equal 12. Awesome. I just had the world's largest deja vu moment. Can't even say it. I'm so excited. Kind of freaked out, if I'm being honest. What do I need to multiply the second equation by in order to have x have a coefficient of negative 6? Negative 2. So again, make sure we use a distributive property all the way through. So we have negative 6x. Take away 10y. And be careful, what's that going to equal? 10. So now I'm looking at this. Remember, we said you can add, you can subtract. In this case, we're just going to add those equations, right? Right down the columns. Here we go. We add. And so we get, what? 11y equals 22. And so we know that our y value is going to be 2. So thinking about our answer is something 2. How do I find x? Plug it into one of the first. Which one, first or second? Doesn't matter. I'd probably use the first one, because I'm a little bit better at dividing by 2 than I am at dividing by 3, even though 3 is my favorite number. So 2x plus 7 times y is 4. And we said y is what? 2. So 2x plus 14 is equal to 4. So 2x is negative 10. So 2x is negative, whoa, kind of running out of room there. Well, hopefully we're all right. So 2x is 10 and x equals negative 5. And then that's it. First one that hasn't had a fraction in it. Crazy stuff. Any questions, comments, concerns, short debates, long debates about setting up a system like that to solve it by elimination? Now, I've got to be honest with you on that quiz that I am going to give you. I'll probably ask you to solve with the elimination technique. And one of the equations is not going to be in standard form. So you're going to have to put it one in standard form. And the coefficients probably won't be the same or opposites. Well, would we be all right with something like that? Okay. I'm sure you'll run into something like that in the homework too. I think we're just about done. There might be some special systems. I think they're going to talk about special systems. Yeah. We'll just look at one of these. Because sometimes you're going to get something really odd, and you need to be able to interpret it. ¿Cómo se llama? Me llamo Mateo. ¿Cuántos años tienes? Yo tengo 40 años. ¿Qué tiempo hace hoy? Hace... ¿Cómo se dice cloudy? Nueve, I think you're thinking rain. ¿Cómo se dice cloudy? No sé. No, yo sé. I know how to say sunny. I say sol. Anyway, so we're going to look at one of these. And real quick, just a little note. If we get a false equation, what do you mean a false equation? I mean something like this. Something like 1 equals 6. Something like 0 equals negative 10. If we get a false equation, does anybody know what that implies about our system? There's no solution and the lines are parallel and they never meet. If we get a true equation, something to the effect of 6 equals 6, something to the effect of 0 equals 0, what's that imply about our system? That it's infinite solutions, that the lines are the same line. Okay? So false equation means no solution. True equation means infinitely many solutions, and it means they're the same line. And what do we classify that as? Wasn't it dependent? Okay, good. So we're just going to look at one more of these. Which one are we looking at? A or B? A. So let's go ahead and boy, this is nice. Let's just add right down the columns. Add right down the columns. What are we going to get? 0 plus 0 equals 0. So we get 0 equals 0, which means it's true, which means infinitely many solutions. It means the lines are the same line. It means it's a dependent system. How are we feeling? Got it? That's all I got today. It's been real, and it's been fun. I'm going to give a shout out to my first period class. They did a really nice job today. I'm going to give a shout out to Hunter Sofer. I want to give a shout out to who else deserves a shout out? Drew. Shout out to Drew. Have a great day.